Okay, so 5 prediction problems on the board there. I guess we get started on those. Couple of reminders. Okay, remember the reactions lab report is due October 3rd. That's Tuesday. Okay, unit exam is going to be October 19th. I know that's still a long way off, but you can start thinking about it. And on Monday, we will do our final assignment on reactions, and then we'll be moving on to the mole equation after that. Okay, and that is the last thing in this course. Or in this course, in this unit, not course. Sorry, I didn't get your hopes up there. Right. Okay. All right, give these ones a try, guys, and we'll walk through them. All right, let's have a look at 1 and 2 here. So we got dicarbon hexahydride. So that would be, well, C2H6. Okay, and it is burning in oxygen gas. What kind of reaction are we looking at? Combustion reaction. Okay. In a combustion reaction, what gets produced?
CO2 and water.
CO2 and water. Okay, so now we've identified the type. We've used the types pattern to predict the products. Okay, I got to check for special elements. I did already. I put a 2 beside oxygen. Okay, are there any ionic compounds I need to drop and swap? Not in this reaction. So what's the last thing to do? Balance. Okay, do I have special balancing rules? Do I need them both? Yes. All right, so I'm going to put a 2 in front of this because 2 is an even number. Okay, 2 times 2 is 4. So now I've got 4 carbons on both sides. 2 times 6 is 12. 6 times 2 is 12. And now I have 4 times 2 is 8 oxygens plus another 6 oxygens for 14 oxygens. 7 times 2 is 14. Okay, everybody all right with that one? Okay. For question number 2, sodium nitrate. So NaNO3. That's a -1. That's a +1. Are you noticing anything different? We haven't done that many where we had the word reaction where we had to predict. What do I have to do also now with the reactants? I have to drop and swap them too, and check for special elements. Okay. So that one's okay. 1 and 1. Reacts with magnesium. Okay, magnesium special. All right, what kind of reaction are we looking at? Single replacement. Okay, so the pattern for single replacement says that the lone element has to replace the part of the ionic compound that it is like. Magnesium is a metal, so it's going to replace sodium. All right, so sodium is going to wind up by itself. Okay, and magnesium is going to end up with nitrate. Does it matter which one I write first? No, I could have written the sodium second and the magnesium nitrate first. Okay, next step, drop and swap ionic compounds. Do I have any of those?
Yeah.
Yes. This is a 2+, this is a -1, brackets, 2 outside the brackets, and check for special elements. Nope, there aren't any. Now what do I do? Now I balance. Okay, only thing out of balance right now is nitrate. There's 2 in the products. Now there's 2 in the reactants, but that 2 also applies to the sodium. So 2 there fixes the sodium, and there's 1 magnesium on both sides. Looks like it's good now. Okay, questions on that one? Some people did on 3. Magnesium nitride breaks down. Okay, what kind of compound is that? It's ionic. Do I need to drop and swap it before I even identify the type of reaction here? Yeah. Okay, so this is a -3, this is a +2, so Mg3N2. Okay, now I only have 1 reactant. What kind of reaction is it? It's a simple decomposition reaction. Okay, the pattern for simple decomposition says that it breaks up into its constituent elements. Again, does the order I write these in matter on this side? No. All right, so obviously there's no ionic compounds to drop and swap because I just made 2 elements, but I need to check if any are. Okay. That one's a 2. Okay. Now I need to balance. Nitrogen already looks good. What do I need in front of magnesium? Yep. Okay. How many people have done number 4? Right, you guys are fast. Okay, number 4, sodium permanganate. NaMn. is a -1, and that is a +1. Is that compound okay? And it reacts with iron 2 sulfide. Okay, -2, and the charge on iron is 2. That's what the Roman numeral tells me, so that compound is okay the way I have it written. Okay, what kind of reaction is it? Double replacement. Okay, so in a double replacement reaction, we simply swap metals. Yeah. Okay, so Fe is going to end up with permanganate, and sodium is going to wind up with sulfur. Okay, I got 2 new ionic compounds. What do I have to do with them? I'm going to drop and swap them both. Okay, permanganate's a -1. Does the charge iron had in the reactants follow it to the products? Yes, it does. Okay. Alright, so we got MnO4 with a 2 outside the brackets. Okay, this is a +1, this is a -2, 3 -2, so Na2S. Okay, I feel like this is going to be solved with one number. Okay, what is it? Okay. When you get like better and better and get more experience at this, you're going to be able to look at reactions like I just didn't go, oh, I got a feeling, and just do it. Okay, because you just kind of see the pattern sometimes. Okay. All right. Copper reacts with fluorine gas. Okay, so this one's got one of those things that we have to be watchful of. Okay, so we got copper as an element reacting with fluorine gas. All right, are either of those special? Yeah, which one? Fluorine, yeah. It's in that 7 over there, okay? All right, what kind of reaction is that? Synthesis reaction. So they're gonna go together like this. Is that an ionic compound? What charge do I use?
2.
Okay, why do I use the 2?
It's the most common.
It's the most common, okay? I had no way to figure out what charge copper had, because when I started this, it was an element with no charge, okay? If it was a double replacement reaction, I could have figured it out, but it's not, so I couldn't. So I used the most common charge instead, which is 2, which means I'm gonna have to put a 2 there, which makes my balancing really easy. Okay, how are we feeling about this stuff? Okay, on Monday, when I give you that reactions assignment, it's going to be 30 reactions. Okay, the first 10 reactions, or first 10 questions, are going to have the reaction written out in formula form with blanks in front of each compound or element for you to balance and then write it in words. Okay, so kind of like our first reaction questions that we started with. Okay, and then the second set of 10 are going to give you the full reaction in words. And you're going to have to write it out in formula form, tell me the type, and balance. The last 10 are prediction, but they're not in word form. So you'll get the reactants in formula form, and all you have to do is predict the products and balance. Okay? It'll be out of 90 marks. 3 marks per reaction. Okay? I think, judging by how fast you're getting through these, that you're not going to have very much homework. Okay? I feel like you're if I give you a full class, which I'm going to do on Monday, all 85 minutes, well, let's say 83, because it'll take me a couple minutes to explain it. Okay, you'll be able to get probably most of it done. And if you don't finish it, you shouldn't have too much left to do. Okay. All right. So these are actually harder, the ones we're doing, than the ones that are going to be on your assignment. Now, I will tell you that the ones that are on your unit exam are like these. Okay, you will get prediction questions on your unit exam that will be in word form only. All right, try the next 5 here. Okay, so for number 6, we have hydrogen sulfate. Okay, so H with SO4, definitely an ionic compound. Hydrogen's acting as the metal, and it has a charge of +1. Sulfate has a charge of -2, so when I drop and swap, I'm going to get H2SO4. And that is going to react with magnesium hydroxide. Okay, Mg, 2 plus, hydroxide, 1 minus, so I'm gonna need brackets around that with a 2 outside of them. Okay, what kind of reaction is that? It's a double replacement, yeah. Okay, so I'm gonna swap the metals, which means hydrogen and magnesium are going to switch places. So hydrogen is gonna end up with hydroxide, and magnesium is going to wind up with sulfate. All right, that's a -2, that's a +2. That one's good, that's water, so I know it's good, okay, but it's -1 and +1. Now I gotta balance the reaction. And right now, I think one number will do it. Where does it go? 2 in front of the water, yeah, okay. By putting a 2 there, I balance my 2 hydroxides and my 2 hydrogens, okay. There's 1 magnesium and 1 sulfate on both sides. All right, tetraphosphorus pentaoxide breaks down. Okay, so I didn't have to drop and swap anything because it's a molecular compound. What kind of reaction is it?
Decomposition.
Decomposition. Okay, so this is going to break down into phosphorus and oxygen. Special? Yep. How special is oxygen? Yeah, it's only a little bit special. How special is phosphorus?
4.
Yeah, it's a little more special. Okay, P4O2. Okay, phosphorus is already balanced, so looks like I got to fix the oxygens. I got 5 on this side and 2 on that side. How am I going to balance that?
Put a 2 in front of
Here?
molecular compound,
Mhm.
and 5 in front of the oxygen.
Right. Lowest common multiple of 5 and 2 is 10. That's what you're looking for when you're balancing. Okay, so 2 times 5 is 10, 5 times 2 is 10, but that 2 that I just put in front of tetraphosphorus pentaoxide also applies to the phosphorus, so there are now 8 of those, so a 2 needs to go here to ensure that those are also balanced. Okay, questions on those two? How many people have done number 8? Okay. All right. Tin reacts with beryllium nitride. Now guys, something I noticed on the quizzes from yesterday. I think some of us are getting, let's say, a little bit overconfident with how well we know the symbols for some of the elements. Okay? Always use your periodic table. Always check. Okay, I don't know how many times yesterday, and it wasn't just this, it was my period 2 class as well, where I had potassium as one of the, it was in one of the compounds in one of those reactions, and people were writing P. Okay, because there's like potassium P, no, potassium is K. Phosphorus is P, more than one element starts with P. Okay, I mean there are 100 and some elements, there's only 26 letters, right? So you know we kind of run out. So make sure guys that you're double checking it. Okay, to get the correct symbols. Tin's another one. I see T for tin, lots. Okay, just because people don't look. Yes. Okay, so tin is SN. Okay, because that's it's old Latin name, whatever that was. Okay, with beryllium nitride. All right, this is an ionic compound because beryllium is a metal. Nitrogen has a -3 charge. Beryllium is a +2. Be3. N2. Oh, lead was the other one. Could put L. L for lead. Okay. It's not L. In fact, we don't have an element that just starts with L. Just L. Like we have lithium and we have lanthanum, but no, just L. Someone with L for lead. And I say, that's an L. Terrible dad joke. Yeah, all right, good. Okay, what kind of reaction are we looking at here? Single replacement. Yeah, we got an element reacting with an ionic compound. Tin is a metal, so what's it going to swap out? Okay, so beryllium ends up alone. Okay, and tin ends up with nitrogen. Is this another one of those weird ones? Does tin have more than one possible charge?
Yep.
Okay, so I have to go with the most common one, which is
4.
4? Yeah, 4. All right, so tin, 4 plus, nitrogen, 3 minus, 4, 3. All right, now we got some work to do. We got some balancing here. So 4 is the biggest number, so we should probably start with that. okay, and that's on nitrogen, so I'm gonna put a 2 here, which is gonna give me 6 berylliums, okay, and I need to put 3 in front of this to balance the tins. Now I think it works. Okay. All right, I'm really done number 9. Okay, so sodium bromide, NaBr. Okay, that's a -1, that's a +1, so that compound is good. Reacts with lead 4 sulfide. Okay, so 4 plus, 2 minus. Okay, what do I have to do when I drop and swap that? I gotta reduce it, right? Okay, so I'm gonna have PbS2, not Pb2S4. Spoiler alert, I put questions like that in the multiple choice, okay? Like dropping and swapping of ionic compounds in the multiple choice, okay? For if I had lead 2 sulfide in there, I would probably have something like this. I'd have like PbS, and then I would have Pb2S4. That one would get picked a lot, okay? And then I'd have like okay? What a lot of those distractor items get people. Okay, like this one here gets people that forget they have to reduce. They know how to drop and swap, they do the drop and swap and they forget to reduce. This one gets people who don't know how to drop and swap. Okay, this one gets people who don't know ionic compounds from molecular compounds. Okay, and that's the right answer. Most people get that one. Okay, let it be you on the test. All right. So what kind of reaction are we looking at here? Double replacement, yeah. Okay, so we swap the metals. So lead is going to end up with bromine, and sodium is going to end up with sulfur. Okay, this was a +4 in the reactants, so it's a +4 in the products. That's a -1, PbBr4. This is a +1, this is a -2, Na2S. Okay. 4, biggest number. So I'm gonna go over here and make sure I've got 4 bromines. And that gives me 4 sodiums. 2 times 2 is 4. That gives me 2 sulfurs. There's 2 sulfurs already over here. 1 lead, 1 lead. We're good. Okay. I'm gonna have done the last one. Okay. All right, sulfur reacts with calcium. S8. All right, what kind of reaction is it? Synthesis. What happens in a synthesis reaction? They join together. Is that what I'm trying to get people to do? Yeah, that's what I'm trying to get people to do. Okay, by simply putting the non-metal first and checking whether you remember that all ionic compounds have the metal first. Okay, all right. Ca +2, calcium -2, looks good already. Now what? Okay, all right, we getting the hang of this? Are there lots of little details to remember though? Okay, and that's why practice is so important. Okay, the more you practice, and you know I'm gonna have questions, like in this set of 10 questions, okay, probably, well, let's see here. So that had a special element, that had the, pick the most common charge, that had the pick the most common charge, that had special elements, that had pick the most common charge. Okay, like at least half of them have got one of those little rare tricks, okay, that comes up. right? But the more you practice those, the more familiar you get, the less likely you are to forget, okay, those little things. So, here's the thing with chemistry, guys. Since we've got like 3 weeks, a little less than 3 weeks till our unit exam, the best way to prepare for a chemistry exam is to practice. Chemistry is skill-based, okay? The more you practice your skills, the better you get at them. There's very little writing and explaining to do in chemistry, okay? On your unit exam, there's there's really just one question where you have to write and explain. The rest are basically all skills, okay? Being able to draw an atom, being able to write and balance reactions, predict reactions, do mole equation calculations, okay? It's all, I know this skill, I'm good at it, I can demonstrate it to you, okay? So chemistry, practice to study. Physics, practice to study. Biology, read, memorize, regurgitate, okay? Yeah, it's true, all right? But biology is much more reading and writing. Like on your biology exam, basically every question will require you to write a paragraph answer, okay? But in chemistry, that's much more rare, right? So how do I start studying for my chemistry unit exam? You do a few questions each night from the digital workbook and use the keys that are included. All right, what do we got here? We got another 12 minutes, okay. I'm gonna give you 3-minute break, and then I'm gonna put a couple more on here. Okay, guys, just the first 5 that are there. These are like the ones that will be on in the last set of 10. Last set of, nice catch. That was like one bounce.
And then it fell, but I got it.
But you got it on the first bounce. I only heard it hit once.
That's true.
Yeah. Okay, so these 5, the first 5 here are going to be like the last set of questions, the last 10 questions on your assignment on Monday, right, where it's still prediction, but it's given to you in formula form, so a little bit quicker because you don't have to do the reactants as well. Okay, so predict the products, balance. Okay. All right, so for number 1, what kind of reaction are we looking at? Single replacement. We wrote water like it's an ionic compound. Okay, so we're looking at a single replacement reaction. So hydrogen is going to end up by itself, and potassium is going to wind up with hydroxide. What do I need to remember about hydrogen when it's by itself? That it is special, right? Okay, and guys, I'm still seeing a few people getting the swap and drop confused with the special number, okay? Remember that when an element is special, it is only while it is an element. If it is in a compound, the number is either from the drop and swap or from a prefix in a molecular compound, okay? And to balance that out, we would put a 2 here, a 2 here, and a 2 there. Okay, for number 2, double replacement reaction, swap the metals. Okay, so we would have sodium ends up with sulfur, copper ends up with hydroxide. Purpose of this question: do I go with the most common charge, or can I figure out what the charge on copper is? I can figure it out. And in this case, it's 1, not 2. Okay, and the reason for that is this is a -2. The only reason I would need 2 coppers is if each one had a +1 charge. So over here, CuOH is correct. That's a +1 and a -1. Okay, this will need to be Na2S. All right, and then I will need to put a 2 in front of this, a 2 in front of that, and then I think we're good. Yeah. All right, everybody with me there? Okay. Fe plus O2 synthesis reaction. Do I have to use the most common charge for iron on this one? And it's 3, isn't it? Yeah. Okay, so we got Fe2O3 for that one. Okay, and we would need to put a 3 in front of this, a 2 in front of that, and a 4 in front of that in order to make it balanced if you're checking your answers there. All right, this is a decomposition reaction, decomposes into 2 different special elements. Okay, have a good weekend, but not too good. See ya.